In even more extremely complex systems, like where India slammed into Asia years and years and years ago, we can get lots and lots of different reverse faults, subduction, normal faults, strike slip faults, everything occurring. So we have India moving up to the right here, mostly up. We have some lateral escape, which is creating strike slip faults, because not all of that is escaping at an equal pace, and not all of it is even escaping. Some of it is just compressing, and therefore getting reverse faults. We have a plate boundary here with extension, so these are ocean ridges and large transform faults. We have subduction. So here it's more straight on, here it's much more oblique, and here it's strike slip. The Indian plate, we had collision along this edge. This uneven edge had some reverse faulting and collision. Here we had a transform boundary. So within the context between two plates, the same two plates, you can have some compression, you can have some transform, strike slip faults, and depending on the shape of them, you could even have some extensional ocean ridge systems or other rift systems. When we have an oblique, so not straight on, collision, we end up with a lot of little strike slip faults, some transform and some transcurrent. So here we have a coastline, we have this accretionary wedge because of this subduction zone, we've got our volcanic arc, but if we didn't have this gray arrow up here in the top right, we would assume that that subduction was going straight into the continent. It's not. So these are not simply reverse faults in the accretionary wedge. There's transform or transcurrent, depending, motion along each of these. So there's lateral motion as well as vertical motion along each of these faults. For the most part, these are going to be transform because they keep ending at another fault. Remember, it doesn't have to end at a plate boundary, it can simply end at another fault. And like you can see here, they keep intersecting with each other. But this motion, the plate that is being subducted, is moving down to the bottom corner of the page, not straight under the other continent. This can happen even when there's not subduction and it's something more like India hitting Asia. It can hit at an oblique angle, and so we get lots of little transform faults to help accommodate the fact that, sure, it's getting compressed together, but there is some of that side-to-side motion component as well. It's like in physics class when you have to break the vector down into the two components. This is the total motion. It has a component that goes straight into the other continent, or straight under it, and it has a component that is parallel to the interface. And that parallel component is what these strike-slip motions are accounting for. And same here. We get lots of reverse faults, but we get some strike-slip faults to accommodate that side-to-side component of these large vectors. This is most easily seen when we have some exotic terrain that gets added at the subduction zone. So when we have oblique subduction, so this plate is moving up, this plate is moving down to the right, there is subduction, and there are some strike-slip faults. In this case, on the far side of this subduction zone, these are transcurrent. You notice they are dying out, they are not continuous, and they do not reach the plate boundary. As this exotic terrain, this is probably some giant island, something like Hawaii, but it's getting closer and closer to that subduction zone as the oceanic crust subducts under that plate boundary. Eventually, this exotic terrain will reach that, but it's more buoyant than ocean crust. It cannot subduct. We talked about that last chapter. So that exotic terrain will get stuck against the other continent. It will stay there, and the ocean that's basically just, we'll call it south, right about where the word time 1 is, will have to break off from this exotic terrain and subduct under it. That changes where the subduction zone is. Now the subduction zone is to the south of that exotic terrain instead of to the north of it, because that exotic terrain cannot subduct. It is too buoyant. It will not go down into the mantle. However, that causes new distortion, new stress that is going to be accommodated by new strain, which involves some of the faults cutting through that exotic terrain. So now that exotic terrain has been cut in half. It's not two separate, islands that got slammed into the other continent. It's one island that got cut in half. And as time goes on, this chunk up here might get cut in half again. Who knows? The way we can tell now as geologists that this was one island, one chunk of exotic terrain, is since it was cut in half by the strike-slip motion of the fault, we'll have chunks of rock or other features or anticlines or something on this one that match up here, and right here that match up down here. It's just like on a small scale we can see some places along the San Andreas Fault or other strike-slip faults that, hey, there's a road and it's been offset, or there's an anticline and it's been offset. Same thing happens with these exotic terrains. You can see features in them that have been offset, and so we know, hey, this was an exotic terrain that got sutured onto the continent and then sheared and cut in half by these strike-slip faults. Within a fold thrust belt, we also get some of this kind of thing going on. We get strike-slip motion because the ramps where there's thrusting going on are not all in one straight line. So there's something has to accommodate the deformation between them, and we call it a lateral ramp. It might be any angle from vertical down to some shallow angle, but it's side to side sliding past each other strike-slip motion. So these lateral ramps are strike-slip faults because that strike slip fault area is ending at one reverse fault and another reverse fault, this would be a transform fault. It is not a transcurrent. Again, it's ending at two faults, so it's transform. Here we can see, instead of a little simple block diagram, we can see a fault map of Kentucky, Tennessee, and Virginia, or at least the intersection of the three states. And we've got a big syncline, big anticline, and then we've got a bunch of reverse faults, and connecting them, some strike slip faults, specifically transform faults. They're intersecting other faults, ending at them, although this one happens to go beyond it. So it ends somewhere further up at another fault. And we can see that these different reverse faults get connected with folding in between in some places and strike slip motion connecting them in other places.